Welcome. Thank you guys all for joining today's Blade session. If you were with us on Monday, we went through kind of some of the basic features of Blade, and today Maggie is going to walk us through some of the more advanced features. Again, we wish we were in person, so since we can't be, we do want this to be interactive, so please feel free to unmute yourself and ask Maggie a question at any time. If you don't feel comfortable doing that, you can always just chat me the questions, and then I can jump in and ask them as well. Pretend like we were all together and we're doing this together instead of on Zoom. So yeah, with that, I will go ahead and turn it over to you, Maggie.
Great. Good morning, everyone. I'm not sure if all of you were in the first training or not, but I'm going to start pretty much where I left off. So if there are any questions in the start for things that if you missed the first training, just bring them up, please. So I believe where I left off with this group is doing the batch printing. So I'm going to start there. So I'm going to actually just grab our sample mechanical STL that was in that folder you received. As you can see, it auto-oriented itself. And if you recall last time when I spoke about batch printing, essentially there's three options within that umbrella. So you can do sequential printing, where it prints one, then the next, then the next, then the next, or you can do, where it's printing them all at once, or you can do multiple models, as in different models printed, in the same G code, but printed sequentially as well. So I'm just going to quickly cover that one more time, just in case there were any questions with that. So you can find that option. So you can start with just one STL. You don't actually have to fill the bed yourself. As I had mentioned last time, this is an automated system within Blade. So if you go up to extensions, you can go to batch printing and you can say populate build plate completely. So this is going to be an option where obviously they print all at once. Seeing as they're so close together, it wouldn't be possible to print them sequentially. So essentially what Blade is doing is it's just filling up the bed to its maximum capacity. And it actually does tell you at the bottom how many parts it was able to fill it with. So for this part, it's able to do 24 objects. Since we're on the, sorry, yet again, my pet is trying to make an appearance on camera here. It's keeping me company. So since this is the studio machine and the gantry is oriented in this direction, that's how it orients the lines for you. For the one, it would be in the opposite direction, as well as the Pro. So I'm not going to slice this because this would, take a long time to slice. But as you can see, it leaves just enough space around for it not to crash. So what I'm going to do is I'm going to just go undo. Stick with that singular STL that I had before, go back to my extensions and batch printing and say populate build plate for sequential printing. So essentially what this does is it populates the build plate in a way so it does just one object at a time. So obviously you might be thinking, hey, we could maybe do 3 across, then 3 across, and 3 across, which is sort of like a balance in between the two. We don't actually have an automated option for that yet. But that is something that you can manually do. But in terms of automation, this is the option we have for printing one by one. So essentially it lays them out, giving space enough in between in there. And then the last option would be if you had multiple different models. So I'm going to hit undo once more, and I'm actually just going to bring in the intake manifold again, just so we can have 2 different models. I'm going to right click on that. And I'm going to hit multiply selected model and just make 1 copy of that. And then I'm going to do the same here, make 1 copy of that. And then what I'm going to do is I'm going to go to my object list in the bottom left-hand corner. I'm going to highlight and select all of these STLs to make sure they're all selected. And then I'm going to go back up to my extensions and hit arrange objects for mixed mode. So essentially what mixed mode means is mixed models, so mixed STLs, but printing sequentially. The one thing you do have to remember to do when you're using this particular mixed mode is to disable one of your extruders. So I'm not sure if I mentioned it in the last beginner training that I did, but we are not capable yet of doing sequential printing with dual extrusion. I know someone asked about the ETA on this, and I have, requested this question to our Blade software team and have not received an answer. Anyone else interested in knowing or really interested in using this tool, please feel free to reach out to me and Abby, and we can keep you updated as to when this will be available. So for now, in order to do this, I do have to deselect that one extruder. And then now it's ready to go. So now if I hit slice, I'm actually going to run this once more now that I deselected the extruder. And hit slice, and we'll see how that runs. The computer is taking a little bit long today. My apologies. Okay, so now we can hit preview. And then we can slice and see that it's doing them sequentially as stated. Are there any questions about batch printing or sequential printing? Okay, so I'm going to move on. I'm going to clear build plate completely, and I'm actually going to switch over to the next thing I wanted to cover is per model settings. So I believe I covered it a little because we had extra time in the afternoon of the basic training. I'm not sure if any of you were in that group. I do apologize because this might be a little bit redundant, but I know in the morning we did not cover it. So essentially what I'm speaking about is if you have an STL model and there's certain areas in the model that you want to have different print settings. So I'm going to switch over to the one, and I'm going to bring in the rim e-bike STL. I'm going to let it auto-orient itself, so that's the best orientation. So for certain parts, you may want, whether it's a part that you're using for a trade show or for a client, or a part where essentially you just want to show some different settings within one singular part. It's particularly helpful when you have a part that maybe is going to be an end-use part and certain areas need to be more structural or have more strength than other parts. Obviously, not all print settings are able to be adjusted within one model, depending on how you're applying those adjustments, but Blade will tell you all of that. So Blade will, only provide you with the options that are available to you. So how you can do this is, I'm going to show you one option first that's a little bit more automated, and then a slightly more manual option. So say you want, since this is a rim, for example, we want the inner area of this rim to have a slightly more robust infill, to be a little bit stronger. So how you would do that actually is you would take what we spoke about last time, which is the support blocker tool. You would click on your part, it would provide you with that transparent cube. And I'm going to go up and scale this so that it encompasses the whole area that I want to, change the infill for. And now I'm going to move this down. I'm going to go to my other view, make sure that it's encompassing that whole area. Okay, so normally what this would do is it would not, make any support for the area where this is overlapping with your STL, but we want to use this tool for something different. So essentially how you would do that, you would select the transparent cube and you would go over here to your left hand tool line here, and you would select this tool here with the 4 small shapes on it. So as you can see here, this is normally what this part is used for. Don't support overlaps. So telling you don't create any support for where the 2 of these models overlap. But we're going to switch that and we're going to say modify settings for overlap instead. So when you click on that, it comes up, and a larger box comes up. Essentially, this is from a past thing I was playing around with. So wall thickness and top and bottom thickness are already selected, but I'm going to change it because I want to just work with infill for this one. So what you do is you click on select settings, and it's going to bring up all the possible settings that you could change for this overlap. We're not going to go through all these. You're probably never going to use most of these, but I'm going to deselect wall thickness and top and bottom. And I'm going to go to my infill tab and select infill density. I'm going to close, and then I'm going to say, okay, so this area, I want my infill to be 50%, whereas the rest is 15. So now I'm going to slice my part. And this will take a few minutes. Are there any questions so far? So the one thing that you'll notice once I have this preview up is that in order to, allow for the difference in infill to happen, it will create a wall in between the two objects. So don't be alarmed by that. It may look a bit strange. It's not actually affecting the exterior of your model at all. It's just creating a wall in between that 15% infill and the 50%. And you'll be able to see this better once the preview's up. So obviously you could change, for example, for this area, you could also add extra top walls, extra bottom walls. You can't change the layer height. That's one thing, obviously, that would cause an issue. You can only change the layer height if you're changing it across the board horizontally. You can't obviously change it just for the center, because if you up it or lower it, the machine doesn't know how to compensate for that, so that would cause a crash. But like I said, all the settings that are actually available will show up in that drop-down menu. So let's go to preview.
Just a quick note while that's doing that, we are recording this and we will send out the link afterwards in case anyone is wondering and wants to watch it again or share it with some colleagues. So a recording will be available after.
Great, thanks, Abby. So now as we scroll down here, we'll see, we have our normal 15% infill here. And then when we get to that cube I created, it's upped the infill to 50%. So as I had mentioned, like I said, it does create a sort of outline around that volume. Like I said, this won't affect, the exterior of your part at all. It's not affecting the overall form. It's just allowing it, because if this infill just stopped here and didn't have something to butt up against, it wouldn't have anything to adhere to. So essentially, it needs to create this wall as a means of allowing those infill changes to occur. One question that might come up is, okay, well, this is a rim and I actually only want this circular area to have higher infill. Within Blade itself, we only have the option of the cube, but you can manually bring in something else. So what I'm going to show you is, I'm going to delete this. So what I did is I created a cylinder in Rhino 3D. And I'm actually going to bring that in now. So now we have two STLs in my model. And you can do this, obviously, it doesn't have to be as simple as a cylinder. You can become much more complex with it. But for now, a cylinder actually works for what I want to do because I want just this area here to have higher infill. I don't want it to actually branch out into these legs at all. So what I'm going to do is I'm going to scale up this cylinder a little bit here so I can see it. So there we have it. So right now it's actually still as a solid object. So this would just print as a solid object. So I need to assign it to be sort of that non-support, that translucent cube that we had before. So what I'm going to do is I'm actually going to go back to my per model settings, have that selected, and click again, modify settings for overlap. You'll see immediately that it becomes translucent. And that means that it's no longer acting as its own STL file. So again, I'm going to go to my select settings. I'm going to close these for now. And I'm going to say infill density, close, and I'm going to up it again to 50%. And so essentially what it's doing is it's doing the exact same thing, but now it's doing it in the shape that I want. So, you know, it could be the same thing. You could say, I want actually everything in here to have high infill except for this outer rim and this grid. And therefore you could model a shape that follows this outline. So it's actually really interesting and super helpful. This was not something that was available to us with the third-party software that we used to use. That was strictly limited to horizontal cuts and horizontal changes. But now, you know, you have the ability to actually change your model in a really organic, really specific way. I'm going to hit slice so we can just have a look at this. And again, vice versa, you could do the same thing where if you said, I just actually want the outer rim to have higher infill, the inside doesn't really matter, you could model a sort of like donut shape that would encapsulate just this outer rim and assign it to be those different settings. Sorry for the in-between slicing time. Okay, so let's have a look at this preview. So it should be pretty similar as we had before, but following the shape of that cylinder now instead. Great, so here we have it. And this can be really helpful also, you know, if you want to keep your part optimized. So as you can see now, we have those extra walls and extra infill just in that circular area, the center of the rim. Okay, so I'm going to move on from the per model settings for now, as there's quite a few other things I want to cover. Are there any questions about this?
Not about this one, but you did get one about batch printing. Can you
Sure.
Can you print two different pieces with two different settings?
Yeah, so essentially you would follow this same idea, what I just showed you. So what you would do, I'm going to actually just switch to a smaller model because this one takes too long to slice. Let me bring in that sample mechanical again. So what you would do is you would essentially use this, let's multiply this. Okay, so I'm going to select both of these, batch printing, arrange objects for mixed mode. I generally like, since we have so much space, give it a little extra space. So what you would do is you would use that tool here. So let's remember to disable our second extruder as well. Should have done that first. Sorry about that. Let's run that mixed mode again. Push this back. you would select that, the support blocker tool again, scale it up to encapsulate this whole part. And then you would go to your change settings. And then what you would do is you would change whatever the settings you wanted to for this particular part. The problem is it's not going to allow you to change layer height or other things which you normally wouldn't. It's not smart enough to understand that you're printing one and then the other, and so you should be able to actually change the layer height on the second one. But you'll be able to change, you know, like the infill or other options like that. Hopefully that answers your question. So I'm going to clear build plate here. So the next thing I want to talk about is a few of the more experimental options that we have over here that we didn't really touch upon last time. So I'm going to bring in, let's see. Let's bring in round base. So I don't know if any of you have used vase mode before. Obviously, it's super specific to the model that you want to print. I grabbed a vase from the internet because it's vase mode, so that's the optimal object to print this with. Essentially, what it means is it's nonstop printing. So it can print a bottom surface and one loop on the outside nonstop. So it's actually technically the most optimized option for FDM because it's extremely fast, no retractions, and no seam. But obviously it works, you know, 5% of the time when you're printing for FDM. But for a part like this, it would work. And for example, you know, I've used it before. People, you know, that are just trying to get a prototype out, not an end-use part, doesn't matter about strength. For example, I mean, I couldn't share this part because it's private, but I did a piece with someone that was a stool. Obviously, we were able to flip it over so that top surface was able to print. The stool didn't need a bottom surface, and we, you know, instead of it taking 3 days to print, it took under a day. So to do vase mode, you would select your object and you'd actually go under special modes on the right. So under special modes, you're also going to find again what I spoke about. That's actually at the top under extensions. There's the mix mode and sequential batch printing options. The mold option I have not used yet, and I'm not super familiar with, so I'm not really going to touch upon that one. Questions about it, you can reach out and follow up with you. But essentially what I'm going to talk about is spiralize outer contour. So if you select that smooth spiralized contour, essentially it's going to turn, that's what base mode is. So if we slice this now, we'll see how that works exactly. Okay, that did not slice properly, too skinny. Give me one moment. Thicken that up. There we go. Okay, so essentially, you have to select also surface along with spiral outer contour. So my apologies for not selecting that first. So now you'll see, you know, this part takes 1 hour and 40 minutes, which is kind of amazing. It does, you know, that single extrusion outline there, and there's no seam. So essentially, it's, like I said, extremely optimized, but really specific to what your part is. If you have a top surface, obviously it won't work because there's no infill inside of the object. It's going to be a completely hollow object. But if you have something like a vase or something you're able to flip down, it also obviously can't overextend that 45-degree angle. So this angle is okay. If it starts to bend a little bit further, you're probably going to have some hanging or some holes in your model, because essentially only having one loop, you know, there's not 2 loops for it to adhere to sort of allow for that angle to happen. Another option though, if you don't want to do spiral outer counter, so if you want more than one loop, but you don't need infill or a top surface, you would actually deselect that, but you would keep it on surface mode. So essentially, normal is, normal printing. So printing all the parts, printing the infill, printing the top surface, et cetera, et cetera. If you want just surface mode, so that essentially is when you can go in and say, okay, I want, 2 shells for my part. I think this STL might be a little too thin, so it might not work, but we can test it and see. We can also, then if it's too thin, use our horizontal expansion option. So let's see if it's thick enough to do the surface mode for now. So essentially, like I said, this allows you to do 2, 3, 4 loops without having to do infill, top or bottom surfaces. So it's essentially just a skin model. So let's see if it did 2 loops. So yeah, we have 2 loops here. You can sort of see that line in between. It's a little hard to see, but maybe nope, this is still the 1 loop. So it's a little too thin. So let's exit out of here. Another option I had talked about was horizontal expansion. I think I mentioned it in the first talk. Again, not an option that is going to work always for you, because essentially what it does is it thickens your model, but in every direction horizontally. So obviously, if you're making a model that's part of an assembly or that needs to be a certain dimension on the outside, it's not going to work. You're going to have to, go back to the drawing board a little bit and work on your model itself. But if it's just a one-off prototype, like say you're just, making a base for a friend of yours, you realize the STL is too thin, you can do horizontal expansion, say, okay, I want to thicken this by 1 millimeter. So now let's see if that's enough to allow for the 2 shells. Or let's even up it to, let's do 3 walls. And I'm going to make the line width 1.0. So let's see how that works. It might still be too thin, and if it is, we can add more to the horizontal expansion. Okay, so now it's doing the 2 lines. So as you can see, because I have it in surface mode only, I made it maybe a little too thick now, so having only 2 loops is leaving a huge gap in between. Not sure when this might be useful to you, but you understand how the process works. So essentially, I would go back, I'd lower that horizontal expansion so that it would only encapsulate 2 loops that are actually touching each other to give it the stability. But again, it's allowing you to do just the surface of a model. Okay, so the last thing I want to talk about under special modes is that tandem mode. I'm not sure if you're familiar with it. Currently, it is only available on the 1. It will be available on the Pro. The Studio will not. It will never be available for. But tandem mode, essentially, if you're familiar with our machines, you know that our BigRep 1 comes with 2 extruders on the same base, but as 2 separate elements, so they move individually of each other. So what tandem mode means is that we actually take 1 extruder and shift it over halfway down the gantry. So essentially, it allows you to, and I'm sure most of you will probably never use this option, but I just want to talk about it really quickly so that you know that it is an option. So essentially what it is that you now have half of your build plate. So if you're using the 1, you essentially have the space of a studio machine, in X and Y anyway. Obviously in Z it's still taller, but it allows you to print 2 of the same model at the same time simultaneously. So, we have very few clients that have gone in for this option because obviously once you implement this option on your machine, you're no longer able to do dual extrusion. But if you're printing one-off parts that you need, thousands of a year, and that's why you purchase this machine, tandem mode can actually be really helpful and really useful and speed up the print time, because essentially the time it takes to do 1 part, you're now able to output 2. So I'm just going to briefly show you how it works. In order to do tandem mode again, you actually do have to disable the second the second extruder. Seems a little odd, but that's how it works, so that it understands it's not doing dual extrusion anymore. So I'm going to just keep with the vase because it's a really simple option. I'm going to turn this back to normal, and I'm going to click Enable Tandem Mode. Okay. So now you can see, it's a little hard to see sometimes, but you can see that the bed now at this view is kind of separated in half. So essentially this is your first half build plate and this is your second half. The other thing to know with tandem mode is you don't actually have to copy your STL over, you just need one. So we have the one placed here. I'm going to scale it up a little bit. And it's automatically going to replicate that on the other side now that you have enabled tandem mode. So when you hit slice, you're going to see only one STL. The time obviously is the time it's going to take to do two, but you do have to implement manually the amount of material you're using. So its output is only telling you that single material. I'm sure this will change as Blade becomes more advanced, but for now, this is how it's functioning. So if we hit preview, so you won't see, like I said, the second STL, but essentially just clicking that enable tandem mode, your G-code output will print both of them. Are there any questions about that? I know it's a little bit odd of a process, but essentially in those 11 hours, you'll get 2 prints. But as I said, when you hover over the info, you'll see that it's only 0.7 kilos, but you'll have to times that by 2 because that's analyzing just the one piece. So essentially to make both, you're going to need 1.4 kilos of material. So I think that's it in terms of special modes over here. Like I said, the mold one I'm not really familiar with, but if molds are something that you're practicing and doing, please reach out and we will get you the info that you need. So I'm going to disable tandem mode. I'll switch over to the studio. Okay, so another thing I wanted to talk about today is dual extrusion printing. So I know that in the first session we talked about it, but only in terms of support versus part. So what I want to touch upon today is actually if you have a model where you want to use dual extrusion because certain parts of it you want to be one color, certain parts you want to be the other. So I'm going to delete this. I'm going to hit clear build plate, and I'm going to bring in, so essentially I modeled, I guess I could also show you the Rhino, but maybe that's not necessary. I'm going to bring in, so essentially I modeled a part in Rhino as, you know, one part overall, but exported it as 2 separate STLs. If it's too confusing, we can go to Rhino for a moment for me to explain that. But let's bring in tray part 1. And I did this very quickly, so my STL is not clean, which is why you're seeing this model errors, but it'll slice okay. I'm going to close these, auto orientation. And then I'm going to bring in tray part 2. So essentially in Rhino, I have them overlapping in the way that I want them to be, as well as when I export them. So Blade will recognize that and it'll place them accordingly for you. I've never had an issue with that. I'm sure that it's happened before that it places them in an odd way. If that does happen though, what you can do is you can just click one part, find the XYZ coordinates and copy them to the other part. And then they should overlap and align properly if it doesn't auto-orient them automatically for you. So essentially this is one part, but I want to print this element in one material and this in another. So the one thing you just have to know is you have to choose, two materials that function on this machine, that function with 0.6 nozzles, and that have the same layer height options, because you do have to print them with the same layer height. So I'm actually, for this example, what I'm going to do is enable our second extruder. I'm just going to say I want the base in black Pro HT. Let's say discard changes. As you recall, we talked about this a little bit in the first session. Whenever you make changes and you bring in a new STL, if you've made changes to the automated blade settings, it's going to ask if you want to keep those changes or not. Since this is a new file, I'm going to hit discard. So I don't want to keep any changes that I made to that old STL I had in here. And then I'm going to have this one at natural Pro HT. So we're actually going to keep it both Pro HT, 2 different colors for this option 1. So the thing is, as you can see now, they're both under T0 extruder. So what you have to do is you have to assign that STL a certain extruder. So you have to right click on your STL, and you'll see here that you'll have 2 options. So it can print with T0 or T1. I want the base to print with T1. So now you can see it's really nice because it'll show you the colors, so you'll know even in advance before slicing it that you've assigned it properly. Or you say, oh no, that's not what I wanted. I want this to be natural and I want this to be the black Pro HT.
I'm sorry.
Sure.
Can I ask, are these 2 files of STL, or did you raise one file and you kind of choose some parts in the same STL file?
Yeah, so maybe I can show Rhino. Essentially, what I did is I modeled them as one part, but then I separated them before I exported them as meshes. So essentially, this part, like if I can't go. This part is all in its own enclosed STL, but it butts up against this one. So when it prints, they will adhere to each other because I want them to be one solid part.
Yes.
But I didn't leave any gaps or holes open because Blade has to read it as 2 enclosed solid mesh STLs. Does that make sense?
Yes, but I'm sorry. Did you draw this file?
No, I did not. No, this was just a sample that I got.
Okay, because I want to know also, like in drawing, how does this, because of course they draw it like as a one part or something, but how do they separate, like let's say the base part from the upper part?
I mean, there's technically the only separation essentially when I'm in Rhino and I've modeled this, because this actually was one part to begin with. So I brought it into Rhino and I essentially selected all the meshes that were in the bottom tray and put them on one layer. And then I selected all these and put them in another. So that essentially I could, hide that. And this would be its own, like this would print on its own fine. So even if I didn't bring that other part in, this is an enclosed solid mesh file. And this is also an enclosed solid mesh file. But I model them so that, the 2 elements, like you see this element here where they touch each other.
Yeah.
Those 2 meshes essentially are almost overlapping or right up against each other. So that when I bring it in here, when it prints, the outer layer of this element will adhere to the outer layer of this one and they'll print as one piece.
Okay. Okay, thanks.
Yeah, of course. And if it's still confusing and there's more questions, we can talk about it. We can talk about it some more. I'm just going to try to cover a few more things and then we'll have like 10 minutes at the end where if it's really confusing, we can look at the initial Rhino file I had. So now that I've assigned it to 2 different colors, I'm also going to say, I want to make sure that my brim is going to print with that natural color. So that there's, just to minimize the retraction. So that's already set. So we have both layers selected. We're doing them at 0.3 layer height. Discard changes there. We know it's set up for dual extrusion because we see our prime pillar. And then I'm going to hit slice. And this one I know takes a little a little while to slice. And as I had mentioned, when I brought in this model, I did this really rough quickly before this call, so I know there's a few issues with it. Another thing that Blade has is mesh cleanup options. They're not, super extensive, and they might not always work if the mesh is really messy. There obviously are outside options, going back and fixing the model. NetFab is another option that cleans STLs. Magix is a very expensive option that cleans STLs. But there are mesh tools here. Very minimal, like I said, but it allows you to check models. So it'll, bring up a pop-up window saying what's exactly wrong with your model. So if you do have to go back and remodel, you'll know where to begin. It does allow you to fix simple holes and fix the normals. So if the normals of your model are facing different directions, sometimes that can cause an issue with slicing. So let's preview this now and make sure that, the assignment of the two extruders worked. So right now in my color scheme, I have it set to line type, so it's quite difficult to see whether or not the dual extrusion was implemented. So I don't think I touched upon this before, but there's a couple different options you can use in terms of how you preview your part. So for this, I'm going to actually just look at material color because I want to make sure we have the two different materials in there. So now we have it. Now you can see that middle part printed with the black Pro HT, the outer part printed with the natural. I didn't mess with the support at all, so it automatically went to T0. That's generally what it does. That's its default. So as you can see, the support is printing in a different color. That's actually fine for me. Doesn't matter. Clearly, if you're using two different materials and not two of the same, maybe that will matter. So you just have to go under support and tell it which extruder you want it to use. And then again, like I said, I had set the brim to print with that natural. So you can see that the brim is also printing. Can have a look here. And then when you hover over here, like I said, it'll break it down to you how much natural you're using and how much black. So if you have like a lot more black Pro HT than natural, and you're like, okay, no, I want the support to print with the black, you can switch it here. Another option for dual extrusion, which we talked about a little bit in the first session, but let's revert to saying we want this whole thing printed with black Pro HT or natural Pro HT. So I'm going to set this back. I'm going to click on this and say I want it to be natural. And I'm going to say I want to use soluble support. So I'm going to go to BBOH natural. I'm going to hit discard my changes from the old settings. Do a 0.3 layer height. And I'm going to go, and it doesn't, again, so when you just change this to BBOH, it's not going to automatically, Blade's not going to say, oh, that person selected BBOH, they clearly want to use that for the support. You do have to go into the support tab and say, I want to use BBOH. And like a good way to know is that if that prime pillar shadow isn't showing up, it's not, implemented correctly. Another great option, which I didn't talk about last time, which is why I wanted to bring this up quickly, is that, BVOH is extremely expensive. It goes, I think, $115 per kilo. If you, not for this part, because it doesn't require a ton of support, but, for example, if you have a part that has, half the build plate up is support, just to sort of catch, a singular surface at the top, you are actually able to tell it, I only want the roof or the interface support, which refers to the support touching the part, to be BVOH, and I want the rest to be Pro HT, PLA, whatever you're using to print. And so instead of just telling the whole thing to be T1, I'm going to keep that T0 and I'm going to say support interface T1. And so this kind of allows you to save some material and time. Like I said, for a part like this might not be necessary, but for parts where there's a ton of support necessary to build the part properly, assigning just the interface support is a really great option to save you some time and money. As we all know, BVOH, aside from being expensive, does print on the slower side due to its water-soluble nature. So let's have a look here and I'll show you how that works with the interface support. Okay, so let's hit preview here. So I am going to go back to my line type color scheme because I want to see support versus BVOH. And because I'm using natural Pro HT and natural colored BVOH, the color scheme of material color is not going to help me. So let's have a look here. So essentially, this dark blue, so essentially all the dark blue, which is the interface support, will print with the BVOH. And the rest of the support will print with the Pro HT. So just yet another option to optimize your print even further. And the last, okay, so there's one more thing I wanted to touch upon, actually two more, and I think we have time. I'm going to go back to prepare. I'm going to clear build plate, and I'm going to bring in, let's see, what can we use here? I'm going to bring that intake manifold back in again, and I'm going to scale it up. Let's see, I'm just going to scale it by eye. Let's make it that big. I'm going to rotate it around. I want to print this just single extrusion, so I'm going to disengage that BVOH support. And I'm going to set the layer height to 0.3. Great, so I'm going to leave it there. I'm not sure if any of you have used, I believe this is under experimental. Yeah, so there's a ton of stuff under here too. I'm not going to go over most of this today. Like I said, if there's specific things you see that you're really interested in, you can reach out. But the one setting that I have used a lot since Blade has come out, which I find really helpful, especially for parts like this, which have areas of really flat surface and then areas of more detail, is a tool called Use Adaptive Layers. So essentially what this does is it'll analyze your part in terms of the resolution it feels it needs to achieve the details. Again, this is maybe not, I maybe should have found like a larger part to use, but this will do the trick for now. But say, yeah, you have a huge flat surface and then at the top you have a really intricate area. This will allow you to, print that huge flat surface with maybe a higher, like 0.5 layer height, and then it'll print that intricate area with a lower 0.2 or 0.3. Generally, whatever layer height you select, like say I select 0.3, it'll go 1 to 2 points beyond it in both directions. So I'm going to select Use Adaptive Layers here. So maximum variation you can change. So you can say, I only want it to go 1 point above or 1 point below, or I want it to go 2 point above and 2 point below. And so I'm going to leave it at 1 for now. I think that's enough. So I'm going to just keep the automatic settings that we've set up for you for adaptive layer height and hit slice to show you. So this really allows you to get sort of the best surface finish and to possibly speed up your part. Again, it gives you, the option to change the stepping size. You can make it even less. Change, again, the variation between layers. Obviously, if you're using the studio, you can't do like a layer variation of, 2 millimeters. That just won't work. You have to stay within what the options are. Let's have a preview look at this. And then in order to sort of see that, I'm going to go up again to my color scheme and change my color scheme to layer thickness. And so now you're able to see, so because I had it on that 0.1 variation, like I said, it's ranging from 0.2 to 0.4. If I brought that up to a 0.2 variation, it would range from 0.1 to 0.5. And you'll see the areas where, and it gives you that key, so you'll see like the in-betweens. So essentially, like I said, all of the really flat surfaces and then, the brim and the base, it's printing at a higher layer height, whereas the bottom, it's printing at a lower layer height. And then, there's some areas that are flat that it finds that are pretty flat that don't kind of run into any of these little details here, where it'll do that, slightly in the middle layer height. Are there any questions about this option? Yeah, so anyways, really great option, optimizing your models. Like I said, the larger your part gets, the more advanced the adaptive layer heights can be. So I'm going to just turn that off for now. And then the last thing I want to talk about is, obviously, that our materials are, our machines are open source for materials. Clearly, we always want to use our materials if you can. We can't always guarantee other materials, but sometimes there comes a moment where you need a different color, or you need something that we don't offer. You are able to sort of create your own custom materials. It's pretty limited right now as to the options you can change. But they are there, and I just want to show you quickly how you can do that, as that's a question that's come up quite a few times with people. So essentially, you would go to your the top two extruders, you would go to Manage Materials, and you would hit Create. So like I said, you'll see all of our materials in here. We'll drop it down, you'll see all the different colors. When you click on them, you'll see the changes update here. And so I'm going to hit Create. Oh, let's discard, I don't need that. Custom material, so I'm going to say it's PLA, but it's purple, a color we don't have. And then here I can actually change it to that color. That's helpful for you. The problem is the only settings we're able to change are the temperatures and the speed. So in terms of like retractions and all of that, you have to do that within this window once you've implemented your material. But say for some reason, default print temperature, it has to be a little bit less. So it has to be 202 for this particular PLA. And build plate needs to be 65. And then you can hit close. So now you have your custom material. The problem is it's not always supported. So the issue is it has to be something that's supported with a particular nozzle, particular machine. And we run into issues a lot with this. So if there is a material that you are going to be using that we don't have as an option, reach out to us if you keep running into this issue, and we can help you to try to implement that into your specific blade settings. So for now, I'm going to just go back to BigRep PLA Black. I think that was it in terms of what I wanted to cover today. I did speak, I guess I actually also mentioned experimental support styles. So we can quickly look at some of those. I have to be honest, I don't really use them, but they are there and they are available to you. The two options are a conical support. So essentially it is what it states. The support smaller at the bottom grows up to catch it. I maybe can find a model that's a little bit better suited to show this. Let me have a look here. Let's bring that gas tank back in. This will be a good one. So if I click enable conical support, you can import the angle for your support. I suggest just leaving it as is if you are ever going to use this. And let's just hit slice so you can see how it looks with our standard double settings here. We have used this successfully, but again, really specific to your model. Sometimes the issues are, it can be helpful when you have a model that has, you know, interior supports maybe, and still has a lot of stuff touching the print bed. For a part like this, it might not be optimal option to use due to there not being a lot of material on the print bed already, and then creating these conical supports is allowing it also to have a pretty minimal amount of that support touching the print bed itself. So there is a risk for that support to topple over. But essentially what this does is it minimizes material use and makes your print a bit faster. This does take an extremely long time to slice and analyze. I do apologize. So since we are running really low on time, I'm going to ask if there's any questions. And maybe we'll get to see this preview before 11 o'clock.
Yeah, hi Margaret, here is from Germany. Could you hear me?
Yeah.
Yes, so I have one question. I saw it on the internet and it would be very interesting for me as well. They worked with a different slicer and they had the chance to, it's similar to the outer filament, that you give the slicer a position maybe in the layer 760 to pause the print, that you can install a battery or a magnet into the print and then resume the print after you worked on it and it goes on. Yeah, it is that you have a lot of holes, or if you need it for the engineering things or anything else. So is it possible to set a custom pause setting like?
It is. Unfortunately, it's not implemented yet into Blade itself. I have done this with clients before where, yeah, they've inserted screws or nuts or, you know, reinforcement bars and things like this. Unfortunately, how we have to do it now is we have to generate that G code and then open it in a Word document and insert the pause manually. So it's not an automated thing yet, but it will be. I can again find the ETA on this. This is something that has come up quite a few times. Clients have asked for this, so it is something that we have on the radar and we are working on. But currently, as it stands, it is a manual operation to do so.
Okay, so could you inform us when you want to implement it, because this would be very interesting, and I'm not able to set something in the G code as you told.
Yeah, I mean, in the meantime, I can help you with that if that is something you really need to do. I can, you know, we can hop on a call and I can show you how to do that.
Okay, that's fine. So how to get your details? So I wrote you on LinkedIn. Maybe there's another way to contact you.
Abby, what do you think is the best?
Yeah, I can, when I send the follow-up and the recording, I can put Maggie's contact in there too. And if you're in Germany, I can also give you a more local contact as well too, to help with some of that as well.
That's okay. Thank you.
Are there any last questions too?
Yeah, let's. All
right.
Yeah, you can stick around and look at the conical support if you want to. You can also leave if you'd like. I'm not sure it worked as I wanted, as it's saying this print takes 9 days, which is highly unbelievable to me. And I think I have frozen my blade. So for that, I will stop sharing. If you do want to, speak about experimental support, please follow up with me and we can do some one-on-one.
All right, great. Well, thank you guys all for joining, and thank you, Maggie. If you do have other questions, a few people chatted me. If you've got specific parts that you need help with, feel free to reach out to the team. I'll put some contact information when I send the recording out. But yes, thank you all for joining, and I hope you guys have a great day. Thanks.